YouTube, in this video we're going to focus on a special factoring pattern known as either a sum of two cubes or a difference of two cubes. And one thing I want to bring up before we look at these two factoring patterns is one that we've seen before is a difference of two squares. And it gets its name because it's a difference of two squared things. But we've said in the past that something like this is so recognizable, we could say that we always know that it kind of factors into a plus b, a minus b, where a is what we would square to get the first term, and b is what we would square to get the second term. So for instance, something like 4x squared minus 25 I recognize as a difference in of two squares. I could just say that in the front of these I'm just going to put a 2x because that's what I'd square to get this, and I'd put a 5 because that's what I'd square to get this. And one's plus and one's minus. So this is so ubiquitous, known everywhere, that we just memorize it. So what I'm going to tell you is this. You can only factor a difference of two squares, but when it comes to cubes, okay, perfect cubes, these are numbers like 1, 2 cubed is 8, 3 cubed is 27, okay, 4 cubed is 64, 5 cubed is 125, let's see, 6 cubed is, I believe, 216. I'm really testing myself here. 7 cubed is 343. You know, recognize these numbers because you're going to see sums and differences of cubes and they both factor. So what I'm going to tell you is the key to sums and differences of cubes is this. They are always going to factor into a binomial times a trinomial. So we say like we've got a two-term thing here and a three-term thing here. And this is true for both the sum and the difference. But what I can tell you is just like you told me, you know, if I had a squared minus b squared, what I could put in these binomials just by saying, hey, those are the things I would square respectively to get a squared and b squared. Then up here what I want you to tell me is if a cubed plus b cubed factors into this, then in our binomial, just up front here, what we're going to get is something where we would put what I would cube to get this a cubed thing in front and what I would cube to get this b cubed thing in the second spot. And this plus right here directly corresponds to what you have right here. So these are exactly the same. And the same thing is true about our difference of two cubes. We can see that this is minus, this is minus. Notice that I haven't really talked about this trinomial over here yet. I just want to establish this right here. So before I talk about this trinomial even, what I want to do is I want to kind of look at these examples that are listed here on the right. And we notice that 64x to the third plus 1 is a cube. We say this is a sum of two cubes. So on the right here, what you'll notice is they actually explicitly rewrite this as the cube of two things being summed. And so they say, well, I would take 4x cubed to get 64x to the third, and I would take 1 cubed to get 1. So looking at this as like our a part here, and this is like our b part, notice that in our binomial, they just wrote our a part, which was the 4x, and then the b part, which is our 1, and this was directly a plus right here because this right here was a plus, okay, this initial sign. So just like over here, I'm going to skip looking at this part right here for just a moment. I say looking from here straight down to here, looking in the binomial, we'd say 3x cubed would give us this 27x to the third, and then 2 cubed, that would give us this 8 right here. So in other words, we have this difference of two cubes and we filled out our binomial. So here comes the second part of this problem. Every sum and difference of cubes, we said factors into a binomial times a trinomial. This trinomial right here, when you look at it, how we determine its terms are always like this here. When we look at this over here, we would get a squared minus ab plus b squared. But what I want to point out is this. We essentially get, looking at your binomial now, remember I said if you can get this, we can get the rest of this. We're going to take the first term times itself, and what that does is it tells us this first term here. Next, we're going to take the first term here times the second term, and that's going to give us this middle term. And then last, we're going to take this last term here times itself to get this last term. So it becomes a times a times b times b. And in terms of the signs that you see here, what you're going to see here is always a positive at the end of this trinomial. And we would say that you always have a sign here that's opposite the sign you started with here. And the sign that you started with here was the same as what you started with over here. So we can just build in these signs after we get these values in here. So you'll notice again here, this was a difference, this is a difference then. And if that's a difference, that's a sum because it's opposite of this initial sign. So what I want to do here is factor these two expressions completely. So we'll start with letter A here, A. And we say we've got x cubed minus 64. Because this has two terms, I would say, well, you know, maybe it's a difference of squares or a sum or a difference of cubes. You can always recognize two-term things might be those special factoring patterns. And I do recognize that these are cubes. So when I factor this, I'm going to tell you, here's the key to it. We're going to write a binomial times a trinomial. And this first part right here is the key to the rest of this. So I'm going to write, well, I would take x times itself 3 times to get this. And I would take 4 times itself 3 times to get 64. So now I'm going to put a minus here just because this is a minus here, and here comes my trinomial. So if you're ready for these terms, we're going to say x times itself, so x squared, x times 4 now, 4x. Notice I ignored the negative there in front of the 4. And then I'm going to take 4 times itself to get the last term. So as far as the signs are concerned, we know that this last one's always positive, and this right here would have to be opposite of this initial sign. So this would have to be a positive. So here comes my favorite part of factoring sums and differences of cubes. I can make you a promise here that this is unfactorable. So when we say factor completely, we mean keep checking to see if you can keep going. This will never factor, this trinomial, if you've factored a sum or a difference of cubes into this form to begin with. So you're done after this part. So letter B here, we're going to make quick work of this one. We say negative 16x to the 5th minus 250 x to the 2nd, factor it completely. Well, the first thing we check for is the greatest common factor. I notice this doesn't look like cubes, so something's up with it. So I say, okay, well, let's factor out the negative here. I'm guessing that 16 is a factor of 250, and we can certainly check this here. We can say 250 divided by 16. Now, I might be guessing wrongly here. I am guessing wrongly. So maybe 8 is a factor of 250. So 250 divided by 8. That doesn't work. How about 250 divided by 4? 4 is a factor maybe of both of these. So 250 divided by 4. And what I notice is that doesn't work. So 2. These are both even. So what I'm going to do is I'm going to factor out a negative 2 and an x to the 2nd. So that's what they have in common. What's left over is 8 x to the 3rd power. And then if I were to now divide this 250 by 2, I'd have 125. And I took out a negative, so I suppose this becomes a positive. And I also took out both of those x's. So when we say factor completely, I notice that this is a sum of 2 cube numbers. So we're going to rewrite this again, and I'm going to put out front this negative 2x squared. Maybe we'll draw an arrow here. Just bring it down. We're going to write our binomial times our trinomial. So let's start with stationing values we need in our binomial. So we say, what could I cube to get 8x cubed? So I say 2x would do it, and how about 125? We could say a 5. So because this is a plus, we'll put a plus here. And what we get on this side here is 2x times 2x, so 4x squared. 2x times 5, so 10x. And then 5 times 5, which is 25. So because this last one is always a positive, we'll put a plus there. And then this here would have to be opposite our initial sign, which is a minus. So this would be the completely factored form of this initial expression because these could no longer be factored beyond this point. Cheers.